Good morning, dear students. Today I am going to start some problems related to isomerase in haloalkanes. This problem lecture is very important for your board examination point of view as well as competitive examination. So today our first problem is identify all the possible monochloro structural isomers expected to be formed on free radical monochlination of CS3 whole twice CS, CS2, CS3. This is NCERT problem. What is our problem? A bigger alkane is given, and this alkane, when treated with choline in presence of UV light, how many major products you can obtain? You know very well, suppose methane is given, and this alkane is treated with Cl2 in presence of UV light. You know very well, CS3, Cl and HCl become obtained. CS3Cl is major product, whereas HCl become byproduct. In similar pattern, a bigger alkane is given. For this type of problem, first we identify the degree of carbon atoms. If you know the degree of carbon atom, you can easily find out the degree of hydrogen atoms. Why? Because the degree of hydrogen atoms depends upon the degree of carbon atoms. If different degree hydrogen atoms are known, then you can easily identify how many monochloro derivatives can obtain. So this is condensed formula of alkane. Why this compound is alkane? Because satisfied the general formula of alkane, that is CnH2n plus 2. 5 carbon atom, it means 12 hydrogen atoms are present. That's why it is known as what? Pentane. If we draw the structure formula for this chemical, then this pattern of structure formula become possible. First we identify the degree of carbon atom. 1 degree, 1 degree, 2 degree, 3 degree, 1 degree. Why this carbon atom is 1 degree? Because this carbon atom is directly linked with only one carbon. This carbon atom 3 degree. Why? Because this carbon atom is linked with other 3 carbon atoms. 1, 2, 3. This carbon atom is 2 degree because linked with 2 hydrogen atoms. Again this is 1 degree hydrogen. All 1 degree hydrogen atoms are not similar in all respect. Why? Because this 1 degree hydrogen is linked with 2 degree carbon, whereas this 1 degree and this 1 degree hydrogen atom is directly linked with 3 degree carbon atom. So left side hydrogen atom degree are similar in all respect. So we have obtained what? 1 degree, 1 degree, dash, 2 degree and 3 degree. 4 pattern of hydrogen atoms are present in this molecule. So first we formed 4 pattern of alkyl groups. Suppose if hydrogen atom is removed from this carbon atom, we obtained this alkyl group. Again, if we remove this 1 degree hydrogen atom, because the lower 2 degree and upper 2 degree hydrogen atoms are similar, so we can obtain what? CH3, CH, CH3, CH. Suppose this hydrogen atom is removed, then this pattern of alkyl group become obtained. So this is first alkyl, this become second alkyl. If you remove this hydrogen atom is 3 degree, so this pattern of alkyl group you can obtain. Suppose this one, third. If we remove hydrogen atom from 1 degree dash carbon atom, because this hydrogen atom and this hydrogen atom are similar in all respect, so we can obtain CH3, CH, CH2 dash, CH, CH, CH3. Fourth number. So 4 different pattern of alkyl groups you can obtain when this pattern of alkane is given. So the number of alkyl groups indicate the number of haloalkane you can obtain, because if first, second, third and fourth is combined with choline-free radical, then monochloro derivatives can obtain. So 4 products you can form when this chemical is treated with Cl2 in presence of UV light. Your answer is 4. Isomers are possible. All isomers are structural in nature, either chain isomer or position isomer you are obtaining. So the first compound become what? CH3, CH, CH3, CH, CH, CH2, Cl. This is our first haloalkane. Similarly, if you consider this pattern of alkyl group, then treated with Cl2, then this haloalkane become obtained. If you consider third one like this, then this pattern of haloalkane become obtained. And the last one, if we consider fourth, all 4 haloalkanes have got different structure. Therefore, their common name and IUPAC name become different. Our next very important problem from NCERT is among the isomeric alkanes of molecular formula C5H12, identify the one that on photochemical chlorination is first number a single monochloride. The second question, 3 isomeric monochloride, and third one, 4 isomeric monochloride. This problem is similar to previous problem, but slightly different. First, we have to understand what is given. C5H12. This is alkane. So first we have to identify how many alkane you can obtain when C5H12 is given. So 3 pattern of alkane you can form for this compound. First one, this is called what? Normal pentane. Second one, isopentane. Why this is said to be iso? Because iso group is present in this structure formula. And the third one, this is called neopentane. Neopentane. Suppose this is first, this is second, and this become third. So 3 structural isomers are possible. With the help of a structural isomer, first we identify the degree of carbon, and the degree of hydrogen is based upon the degree of carbon. So if different degree hydrogen are obtained, we can identify how many alkyl group can form. If alkyl group is known, we can obtain how many product. You can find out when alkane is treated with choline in presence of UV light. Photochlorination means any alkane is treated with halogen in presence of sunlight, or you can say ultraviolet light. Here 1 degree, 1 degree, 2 degree, 2 degree, 2 degree. All 2 degree hydrogen atoms are not similar in all respect. So suppose this is 2 degree dash. 1 degree, 2 degree, 2 degree dash. 3 product you can obtain. So for 3 isomeric monochloride, we can write what? For this question, the answer is what? Normal pentane. A single monochloride. Here, all carbon atoms are 1 degree. So only one pattern of hydrogen atom are possible in this chemical. So a single monochloride become obtained when this alkane is treated with chlorine in presence of UV light. If we consider isopentane, here 1 degree, 1 degree, 1 degree. All 1 degree hydrogen atoms are not similar. Suppose this is 1 degree dash. So 1 degree dash, 2 degree, 3 degree. It means 4 substitution reactions are possible when this chemical is treated with what? Halogen, that is Cl2 in presence of UV light. So a single monochloride obtained if we write down what? Neopentane. So neopentane is the answer for first problem. 3 isomeric monochloride, the answer become what? N-pentane, normal pentane. And 4 isomeric monochloride become obtained with the help of isopentane. So these are the answer: neopentane for first question, normal pentane for second question, and isopentane for third question. Suppose this chemical is given and treated with Cl2 in presence of UV light. All hydrogen atoms are equivalent and they are called 1 degree. That's why only one mono substituted product become obtained. Like this. Similarly, we can find out how 3 products can obtain in second question and how 4 products can obtain in third question. Consider our next problem. Third, this is also NCERT problem. Write structures of different dihalogen derivatives of propane. In this question, suppose this is the condensed formula of propane. When this alkane is treated with halogen 2 times, it means 2 hydrogen atoms are replaced by 2 halogen atoms. Then how many products you can obtain? For this, we can obtain, suppose 2 hydrogen atoms are replaced by first carbon atom. This is first, second, third. It means 1,1-dihalopropane. 1,1-dihalopropane. Because according to question, dihalogen derivatives can obtain. The second one, suppose if both hydrogen atoms are replaced by halogen, if we consider second carbon atom, the naming of this compound become 2,2-dihalopropane. Similarly, if hydrogen is removed from first and third carbon atom, then we can obtain what? One three dihalopropic. And the last one, if hydrogen is removed from first and second carbon atom simultaneously, then we obtain what? One, two dihalopropic. So this is first, second, third and fourth. The naming of all dihalo derivatives are different. Therefore, 4 structures isomers are possible for this pattern of alkane. One thing always remember, when 2 halogen atoms are present on the same carbon atom, this product is also known as gem product. Gem, G-E-M. You can also say what? Gem dihalopropane. But when 2 halogen atoms are present in different carbon atoms in continuous carbon chain, like this chemical is known as weak. So you can say what? Weak dihalopropane. Similarly, this compound is said to be what? Gem. Here, 2 halogen atoms are present on first and third carbon atoms, not occur continuous chain. That's why the only one name, that is 1,3-dihalopropane for this chemical. Consider our fourth problem. That is, a hydrocarbon P was found to have vapor density Vd become 36. It forms only single monochloro substituted product. Then suggest the structure of P. What is given in question? Vapor density 36. We have to identify a structural formula. Since monochloro substituted product become obtained, so our chemical become alkane in nature. And you know very well the general formula of alkane is CnH2n plus 2. This is the general formula for what? Alkane. Since vapor density is equal to 36, you know molecular weight is equal to 2 into vapor density. 2 into vapor density 36 means what? 72. 72 is the molecular weight, or you can say molecular mass for our alkane. So we can write 12N plus 2N plus 2 is equal to what? 72, or N is equal to 5. That is C5H12 is our alkane, because putting the value of N in this general formula, we obtain C5H12. According to question, how this alkane become arranged and gives only one monochlorosubstituted product? We know very well 3 different types of structure isomers are possible for C5H12: normal pentane, isopentane, and neopentane. If we consider neopentane, then all carbon atoms which is linked with central carbon atom become 1 degree. So such hydrogen atoms are also 1 degree in nature. If degree becomes similar, then only one monosubstituted product become obtained. So if neopentane is given, then when it's treated with Cl2 in presence of UV light, you will obtain what? Means 1 chloro 2,2-dimethyl propane. 1, 2, 3 become product for this chemical. So our answer for this question is what? Neopentane. So neopentane is the answer. That is, the structure of P is neopentane. This becomes P. In next lecture, we will start the topic, the nature of CX bond and method of preparation of different types of haloalkanes and haloarenes with the help of some suitable reagents. Thank you.